Just as science seems to solve our problems, so it creates them. As populations expand, so the pressure on natural resources increases, threatening the traditional way of life of many communities. Welcome to Crete. Summers here are getting longer, hotter and drier. Great for the booming tourist industry, but not so great for farmers like Nikos Epitropakis. He's worried that fresh water resources are starting to run out.
Είναι σίγουρο ότι στο μέλλον όλες οι περιοχές θα αντιμετωπίζουν πρόβλημα λειψιδρίας, γιατί οι ανάγκες αυξάνονται. Ουσιαστικά αυτό είναι το μέγα πρόβλημα που θα αντιμετωπίσει η επόμενη γενιά.
In the 1970s, when the island was facing catastrophic water shortages, farming was in sharp decline. To solve the problem, the government drilled deep boreholes to reach subterranean freshwater streams. Some of the water that Nikos draws from the boreholes today can be recycled, but not enough for the long term. So what happens when those streams dry up?
Το πρόβλημα που αντιμετωπίζει η περιοχή μας εδώ πέρα είναι ότι δεν υπάρχει κάποιο άλλο σχέδιο Β, ας το πούμε έτσι, που να κάνει αυτές τις εκτάσεις καλλιεργήσιμες.
Frustratingly, there's water all around the island, but one bucketful of salt water could kill the hardiest crop. But what if there was a way to desalinate, to filter out that salt?
Η θάλασσα είναι δίπλα μας και είναι μια αστήρευτη πηγή νερού. Η αφαλάτωση, αν ήταν φτηνή, με φτηνή ενέργεια και χαμηλό κόστος, θα μας έλυνε το πρόβλημα λειψιδρίας στο μέλλον.
To find a possible solution, we're going north. Denmark, a country that's not short of water. In Copenhagen, researcher Sylvie Brackvelt and her boss Claus Nielsen are developing a revolutionary new material that could increase our freshwater supplies. Their inspiration was right under their noses, their bodies.
The whole idea came in the context of biomimicry, which basically means that you use principles from nature to apply them in industrial environment.
We're all made up of trillions of cells, and each cell wall has minuscule channels that let water into and out of the cell. These channels are made from proteins called aquaporins.
The aquaporin channels, they have been designed by nature during billions of years of evolution to filter water and only water molecules. So they're very essential for human life.
They do this by the natural process of osmosis, drawing water through the aquaporin channels into the more concentrated solution within the cell, but leaving salt ions behind. But how has the team used this natural osmotic pressure to filter water outside of the human body? Incredibly, they've developed a new material that mimics the cell wall.
So we've developed a technology to print those aquaporins embedded in a polyamide layer onto a support membrane. Right now we are producing around 1,000 meters per week.
Embedded into the surface of the material, the aquaporins only allow water molecules through. Everything else, including salt, is filtered out. But how does this material improve on existing filtering systems? A large water filtering plant works on the same principle as a coffee plunger. It's an effort for Sylvie to push even this small amount of coffee through the filter. Now imagine that scaled up millions of times.
It costs a lot of energy to push water through these filters, which means that the membranes get dirty very soon. So you need a lot of chemicals to clean them. So it's basically very expensive.
And it takes a huge toll on the environment. But the new aquaporin system is low on energy and on cost. So now Sylvie wants to test it in the real world. If the aquaporins could filter the salt from seawater, Nikos's future could look very different.
Hi.
Hi, I'm Sylvie.
Nikos.
Sylvie wants to show him, with a simple demonstration, how aquaporins could be used to water his crops. First, the raw material, seawater.
So all we need to do now is wait.
On one side, the seawater. On the other, a more concentrated liquid fertilizer. Through the process of osmosis, water will naturally be drawn, as it is in the human cell, towards the more concentrated solution. In this case, the fertilizer. If you put the aquaporin material between the two solutions, water molecules, and only water molecules, pass through to dilute the fertilizer.
Όντως, έχει παραπάνω νερό. Είναι πιο αραιωμένο.
So, water from the sea now pure enough to water Nikos's crops. But aquaporins don't just work on seawater. They can be used to filter out pollutants and contamination.
There's lots of people in the world who are lacking water, but they don't have the energy to make water. So the potential of this technology is huge.
Καλό αποτέλεσμα πάνω απ' όλα και να είναι θετικό για τον τόπο μας.
New low-energy technologies such as aquaporins will become ever more important to communities vulnerable to the threat of water shortages, providing them with a real chance of a sustainable future.